Hello everyone, welcome to the course Data Structures. This is Thulasi Chitra, Associate Professor, Department of CSIT, MLR Institute of Technology. Let us see today's overview of the course. In this course, we will be seeing about what is TRIE, introduction to TRIE, and what are the different types of TRIEs we have. That is, we have three different types of TRIEs. One is standard TRIE, another one is compressed TRIE, and another one is suffix TRIE. Regarding this, we will look into it. And just to see the introduction part of TRIEs, here when we are going to see about the TRIEs, up to now whatever we have done in the searching trees, we worked only on collection of numerical values, right? Now all the search trees are used to store the collection of numerical values, but they are not suitable for storing the collection of words or strings. For that, we have come up with a new concept called TRIE. What is this TRIE? TRIE is a data structure which is used to store the collection of strings, make searching of pattern in words more easier. This TRIE data structure will be help us to search the pattern words very easier. Okay, and from where the term TRIE has been taken. This is the word taken from the word called retrieval. In that you are going to have the TRIE. Retrieval, we are going to have the word called TRIE. Okay. Now, this TRIE data structure makes a retrieval of string from the collection of strings more easier. More easily, we are going to retrieve the string that was present in the text or not. This is going to be done. Now, TRIE is also called a prefix tree. TRIE, the other name for TRIE is a prefix tree or sometimes called as a digital tree also. And how this TRIE, that means prefix tree or digital tree, we are going to construct. Now let us look into this. In TRIE, every node except the root node stores a character value. Except the root node, the remaining all the nodes which are going to represent is going to have a one character value. And every node in the TRIE can have one or more number of children. Okay, you can have one or more number of children that can present for a TRIE, and all children of node are alphabetically ordered. And when you are going to represent the children, those should be in the alphabetical order. And if any two strings have a common prefix, suppose I am going to represent bean, right? Same prefix if I am going to have, then they will have the same ancestors. That means I can represent B like this, bean like this, right? Like this way I am going to represent the same ancestor you will have, right? That is the meaning of the statement, right? Now let us come into the example. Now you can see here, suppose if we have given a list of strings like this, cat, bat, ball, rat and bee. Now how I am going to construct this TRIE? And this is the one which we are going to see is a standard TRIE, and we will look some more points regarding the standard TRIE in the next slide. Okay, and when you have given a string, in this case you are going to represent all the strings in the alphabetical order, right? Check its alphabetical order based on the ASCII values we need to check, and we need to write that in the alphabetical order. If you could see cat, bat, ball, rat and bee, and in this the first one you are going to get it is ball, then bee, and then bat and bee and cat and rat. B is having capital B is having the lowest value compared with the capital C and capital R, right? If I am going to have starting B with the 3 strings, then again we need to check with the next character. The second character we need to check, and then we need to place accordingly. A is having 97 and E is having more than that 97. That's why we are going to place B at the third place. And I am going to check with L and T. L is coming first and then T will come later. That's why we are going to place the strings in this alphabetical order. Now construct a TRIE for this, right? Now initially you don't have, for root node you don't have any character, that's why it will be considered as empty or some null. Now from there we need to start representing the remaining strings. Now ball, how I am going to represent this BALL, like this way we are going to represent. At the end of the particular string we are going to end with a dollar. Okay. Next bat, BA already is there. Those two characters are already present. From there we need to extend and represent T, right? And then if you are going to see B is already present. From there, from the transistor only, we are going to connect E, and it is going to end with $. And the next one is cat. This is a new character which you are finding, right? So that we need to start with the new node, CAT, cat, right? And end with the dollar symbol. And the next one is a rat. Again, it is going to start with a new character. That's why we are going to represent separately. Like this way, we are going to construct a trie. Now, let us see what are the different types of tries we have. And we have standard trie, compressed and suffixed tries. First, we will be seeing about the standard trie. The standard trie is an ordered tree for building the strings of set S. S is nothing but the string, such that each node is labeled with the alphabet except the root node. What we have seen in the previous example, the same thing. The children of the node are alphabetically ordered, and path from root to external node should produce the string from S, right? The same thing what we have seen in the previous steps, the same is represented in the standard trie. Let us see the example what we have here. Here you have given a string with the bean, bell, big, bull and bug, set, stock and stone. These are the strings that was given. First, whatever the strings that was given, write them in the alphabetical order. I told you, right? If you need to check the ASCII values, based on that we need to represent, right? Based on the alphabetical order, you are going to get bean, bell, big, bug, bull, set, stock and stone. These are the alphabetical order, the strings you are going to get. Now try to construct the standard trie for it, right? First, it will be the root node will be the null value. Then first you start representing bean. I am going to construct here BEAN, bean, and it should end with $. Next you have bell, BE already present. We are going to represent LL, right? And it should end with $. And how I have represented here in the same way, you can check it. And big, right? Big. Next it should end with $. Next we have bug, BUG, and end with $. And bull, already you have BU. The remaining characters we need to represent with a new node, right? And set, this start with a new characters, that's why we need to represent them separately. SET, set. Then we are going to have stock. S is already started. From there we need to represent stock, STOCK, and at the end we need to represent the $. That represents the end of your string. And ST is already there, O is also there. From there you need to extend N and E, right? You can check this diagram here, the same thing which I have represented, right? Like this way we are going to construct the standard trie. And when you are going to see about the standard trie, the searching, insertion, deletion operations are going to be done with the time complexity of big O of DM. What is D represents the size of alphabet, and M represents the size of string parameters. That means based on which operation we are going to do this, whether you are going for searching, whether you are going for insertion or deletion. Okay. Now this is the time complexity. And what about the space complexity? If you can see the tree, that is the tree which we have constructed for the given strings, then in that the space complexity, that is space, how much it is occupying. In the memory, how much space it is going to occupy. But for the standard trie, it is going to occupy big O of N, right? That is the size, that is the space it is going to occupy in the memory. And N represents the total size of your string, right? This is the time complexities. Because of this, there is some disadvantage with the standard tries, so that we are going for compressed tries. In the standard tries, what is the disadvantage? We are using lot of space. Individually we are representing, and we are extending our tree individually, and we are representing them, so that we can reduce the space in the tree, and so that we can overcome with the standard trie. That is, the disadvantages can be overcome with the standard trie, and that can be done by using the compressed trie. What we are going to do in this, a compressed trie is a kind of standard trie with the nodes of degree at least 2. At least you can have a degree of 2. Up to now we have represented only 1. Now we can increase up to at least 2 means 0, 1 and 2. Up to 2 we can store, right? It can be accomplished by compressing the nodes of TRIE, right? We can compress the nodes and we can represent the standard TRIE what we have constructed. Based on that we can compress and we can represent it. And it is also known as the radix TRIE. The other name for this compressed TRIE is radix TRIE. And it is used to achieve space optimization. I told you, right, in the standard TRIE we are using more space complexity is more, and by using this compressed TRIE we are going to reduce it. And first, for constructing this compressed TRIE, what we are going to do is, first the given set of strings, construct a standard TRIE. What are the string you have given? The same rules to be followed. Alphabetically you have to represent the string and construct the standard TRIE. Then convert it into compressed TRIE. We need to compress and we can represent it. And how we can compress it? Simply whenever a node having only one path, then combine the parent and the child into one node. You have only one path. In that particular case, combine few of them and parent and child into one node and we can represent them. And at the end of the string, we are going to represent the dollar. Let us see the example how we can represent it. Suppose this is a single path, right? For bean, the same thing. I have taken the same previous example. For that, how we are going to represent the compressed TRIE. This is the compressed TRIE variable. This is a path, single path, bean, B-E-A-N, right? Now I can compress this up to A-N. Why? Because E is extending to some other string. That's why I can't compress up to B-E-A-N, right? I can compress A and N can be compressed. And at the same time B-E-L-L. And these two things can be compressed. L-L can be compressed. And if I am going to see big in this also, we can compress IG. And if you see bug can't be compressed. Why? Because U is extended for another string also, so that we can't compress it. Now, if you could see bull, B-U-L-L, yes, L-L can be compressed. At the end, every end we are going to represent with the dollar. And can we compress the set? No. Why? Because it is a single one, you can't compress it. And if you can see the stone or stock, yes, already here we have TO is repeated for stock and as well as the stone, so that we can compress it. And for CK can be compressed and NE can be compressed. Okay, like this way we can represent the compressed TRIE. Now to represent the compressed TRIE in a compact representation by using an array of strings, like a two-dimensional array representation, we can represent the compressed TRIE, right? Now what we are going to do here is, how many strings we have? Give that indexing. We have 7 strings, right? 0, 1, 2, 3, 4, 5, 6 up to 7 we have given. And the indexes for it is start representing the character by character representation. Each character will store in one memory location, so that we are going to give the numbering for it. 0, 1, 2, 3, 4. How many characters that was present? Based on that we can represent these indexes. After representing this, now we need to represent the compact representation for this. Now, how to represent the compact representation? Before going to see this compact representation, here you need to know about, this is the compact representation. Based on its indexes, we are going to represent. Now, you can see here, what is the compact representation here we are going to do. Here, the compact representation is nothing but a node is represented with I, J and K. With these 3 values, we are going to represent. And I represents the index of the string from 0 to 7. And J represents the index of the word in the I string. That means the string which you are going to take in that I. In that we are going to represent the J value. And in ending index of this word in the string I. K represents the ending, J represents the starting, and I represents the string index. The start, which string index, string 1, string 2, string 3, like that way we are going to see. Okay, and now how I am going to represent this one, let us look into this one. Initially the root node is empty. Okay, now you can see this one we have taken it from this compressed TRIE. This compressed TRIE we need to take and we need to represent it. The first one which you have is B, right? Here we have B. If you could see, let me represent the compressed TRIE here. B, S, this is S and this is E, this is A, N and this is L, L which it is representing. This is IG and this is representing U and this is representing G, and this is LL, and this one is SET, and this one is STO, this is CK, and this one is NE, right? Like this way we are going to represent. Now, how these values we are placing here, 0, 0, 5, 0, all these things. I told you that I represents the first in I, J, K. In this format we are going to represent I, J, K. I represents 0, that is the string index where we are going to represent. J represents the starting of the string, and K represents the ending of the string. This is the one which we are going to see. Now you can look into here. For B, what is the string we have? The first string, that is S of 0, for that we are going to represent. So that we are going to represent a 0 for it. And what is the starting index for it? For B, 0. That's why we are going to represent 0. And for K is the starting, 0, for B, 0 is the starting and 0 is the ending. So that we are going to represent 0, 0, 0, right? And now if I am going to see for this, how I have represented E value, right? E, this is the starting string, that is because of string 0, we have represented 0 here. Then followed by the starting, where is E starting? E is starting at 1 and ending at 1. We have only one character there. That's why starting and ending will be the same, right? Now coming to EAN, if you are going to see. This is the string for S of 0, and 2 represents the starting of A, and 3 represents the ending of N, okay? Like this way we have represented this 0, 2, 3. If you could see for the same LL where it is, this is for the second, that is string index 1. That's why the starting index I have represented with 1, and L represents the starting of the string, that is L represents the starting position, and 3 represents the ending position. In the same way, if you can look into the remaining cases, the same thing will be there. For you understanding one more, I am going to tell this CK. Where we have C, right? This has been started for 5 stock, right? S is the one which I am going to start. That's why we are going to start with S as 5, 0, 0. 5 is the starting index, that is a starting string, and 0, 0 represents starting and ending of S. If I am going to see for TO, yes, this is the string for 6th index, that is I have represented I as 6 and J as 1, where this T is starting at 1, ending at O, that means 1, 2 I have represented. You can check for the remaining cases, you can try it, right? You can able to do it. This take this reference and try to solve the remaining. Now the last one is the suffix trie. The suffix trie is nothing but a trie data structure in which all the suffixes of the string are shown. We are going to take only the suffixes, and based on that we are going to construct. And when a suffix trie for a string A has been constructed, it can be used to determine another string B in a substring. Suppose I am going to take a string, let us see with the example so that you could understand what is that statement. And here suppose construct a suffix string for the string minimize. In this we are going to have the substrings, right? B is a substring of A. Suppose what are the suffixes for minimize? You have E, that means you need to start writing from the last. E, ZE, IZE, MIZE, IMIZE, NIMIZE, INMIZE, NIMIZE, right? From the back onwards you are going to start writing, right? From character by character increasing we are going to write the suffixes. Suffixes means last, prefix means the starting, right? Now based on that I have written it. Now if you could see the remaining part of all these, all are the substrings of the string which you have taken, that is A, right? This is the one which it is telling you about. Now how we are going to do this? Now we need to construct when I want to represent this construction of suffix trie, first what we need to do is, first you need to write the suffixes and represent them in the alphabetical order, right? Now try to construct the tree. Now for this try to construct a standard trie. First what you are going to get? You are going to get E and dollar. then you are going to have I, M. Individually we are going to represent for suffix trie, right? Z and then E and represent with a dollar. And for I, from I itself it is starting, right? N, I, M, I, Z, E and dollar. And from I itself it is starting with this ZE. And the next one which you have is M. The complete one you need to represent. N, I, M, I, Z, E. And here also M is already there, I, Z, E. And the last we have, it is starting with N. We need to represent them separately. It is starting with N, N, I, M, I, Z, E and end with the dollar. For everything we need to end with the dollar. And the last one which we have is ZE. Okay, and it should end with the dollar. Like this way we need to have the construction of standard TRIE. Now after that we need to compress it. We have seen the representation, how you are going to compress it. You can compress this one, right? You can look into this and you can compress which can be compressed, that can be compressed. And you can have the representation of compact representation of this. For easy understanding, I can write minimize, right? And give the numbering for it 1, 2, 3, 4, 5, 6, 7, 8. From 0 onwards we need to write, sorry. From 0 onwards we need to write. So that you are going to get up to 6, 7, right? 0, 1, 2, 3, 4, 5, 6, 7. Based on this compressed tree, we need to represent this suffix trie. That is compact representation we need to represent. Like this way, you can able to represent, what is this? What is the previous one? It is representing E. E is representing 7. That's why I have given 7, 7. The other one, I. I is repeating for twice here and here. Either you can represent any one, 1, 1 or 5, 5, anything can be represented. And you can look into this MIZE. MIZE, here you don't have any representation of starting position. Right? That's why we are going to represent 4, 7 directly. MIZE, for that we are going to take only the starting and ending. We are going to represent that particular string where it is starting and where it is ending. M is 4, ZE. This is the complete one, right? That's why we are representing with MIZE. One of the character is not represented here. I, J, K is there. In that I we are not mentioning, just we are representing the string starting and ending. Like this way you can check and construct for the remaining cases also. And you can able to try suffix tries for this, all these examples you can try it. And if there is any doubts, you can please do comment in the comment section. And the overall summary of this course is where we have seen the introduction. We have seen about the different tries, that is standard, compressed and suffix tries. All this we have seen. Thank you.